My name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and we're hosting today's webinar on graphene functionalization. What is it? Why is it important? For those of you who are not familiar with the Graphene Council, we are the largest community for graphene and other 2D materials. We reach more than 35,000 materials professionals, of which about 10,000 are academic, university-based, mostly postdocs, and the others are in the commercial space. We are very active in the establishment of international standards and have recently submitted the graphene classification framework to ISO to become an official technical specification. We also write the graphene report, more than 700 pages on graphene production techniques, applications, commercial aspects, patent reviews, and a review of over 200 commercial producing graphene companies. We also issue weekly graphene intelligence briefing, which covers commercial, patents, and research news. And we advocate on behalf of the industry, helping with webinars like today to educate and inform about what graphene is and how to use it. Graphene is this amazing material that can be used in many applications because it is electrically conductive, thermally conductive, strong, etc. And that lends it to use in all of the applications you see here and more. The Graphene Council supports the graphene industry through a wide range of services and information. This is a list of everything we do here, including the Verified Graphene Producer Program. If you have any questions about the Graphene Council, how to get involved, or if you're interested in using graphene or developing an application for your company, please contact us. We'd be happy to help you. The Graphene Council is a neutral, independent body. We do not produce graphene ourselves. We connect the people who do, research it, use it, and put it into applications. And with that, I'm going to stop sharing my screen and I'm going to invite our first speaker, John Mark from Haydale, based in the UK. John Mark, if you want to go ahead and start using the screen, and we're going to hear about Haydale's extensive experience in the field of functionalizing graphene. And as we say, what is it? What do you do? And why do you functionalize graphene?
Thank you, Terrence. Well, once again, it's a pleasure to be presenting on the Graphene Council webinar. Solving the graphene challenge. Many nanomaterials, like graphene, come as powders. They are inert and do not mix. They need some sort of surface treatment to make them effective in application. People have been trying to solve the challenge using many methods. These often rely on surfactants, high energy mixing, non-covalent chemistry, etching, and other methods. Many of these methods suffer from a lack of stability and scalability, and the effects of impurities and unwanted chemistries in the process. These can be time-consuming and can produce high levels of effluent, and yet still products underperform. Haydale's HD Plas method is an environmentally friendlier, dry, clean process that unlocks the property of graphene to give products improved mechanical, electrical, and thermal properties. As shown in this diagram, when unfunctionalized graphene or other raw materials are dispersed into a matrix, such as a resin, solvent, or water, there is no compatibility with the nanomaterial. This results in bad dispersion and matrix interaction, resulting in poor performance. Whereas, if we can functionalize the material, we will see the correct compatibility with the formulation and interaction with the matrix. Haydale's approach to functionalization has been to utilize plasma as the means of covalently bonding the surface chemistry to graphene and other advanced materials. Why plasma, though? Well, plasma is already widely used in industry for metallurgy, semiconductors, cutting, welding, and cleaning. In automotive and printing applications, plasma is known for its ultrafine cleaning, removal of weak boundary layers, modification of the surface topography, cross-linking of the surface molecules and reduction of metal oxides, and most importantly, deposition of functional groups. The matrix in the center of the slide shows some of the chemical reactions by plasma in a damp atmosphere. These attributes of plasma are well known, and if these can be controlled and applied to a nanomaterial, then there's the potential for improving the surface chemistry of this given material. These benefits and more are what makes Haydale's approach truly unique. So being able to plasma functionalize graphene, yet alone a more traditional material, has been an immense engineering challenge. Haydale has been able to develop, validate, and scale our HT-Plas process through our fleet of patented plasma reactors, providing the level of tunability and control to support our customer needs and our own product offering. These machines are developed, ready for high volume manufacturing, with tonnage orders already supplied and customer site audits completed. This is our HT1400 system that we took delivery of March last year. You can see in the final cut of this video, we have a high volume, stable plasma, consistently treating graphene and functionalizing the surface. This shot is taken inside the HT1400 plasma reactor. Now, we've got 3 key points to combat the graphene challenge: plasma functionalization, advanced materials, and a means to combine them in our reactors. So this is why, bringing it back to our initial slide, graphene is inert and won't disperse. Vial on the left demonstrates the graphene challenge well. Now, industry have been working with this, overcoming it either with high loading, additives such as surfactants, high shear mixing, and other methods. These all increase costs in manufacturing and impact on quality. On the right is the same material, same amount, treated with our HT60 lab scale reactor. This is less power than a kettle. Now, this is the required functional groups that want to interact with the matrix, thus the property of graphene is unlocked. Now, we don't only improve dispersion, but we can add specific functional groups that change the property of the material and thus adding additional benefit to the end product. So Haydale is not just a functionalized powder supplier. The graphene challenge requires more of a wider scope of understanding. Haydale provides end-to-end support to deliver our customer product uplifts requirements, a holistic approach, if you will. We always first start with what the requirements are from the customer, not what graphene can do, but instead what is the need. Often we have an off-the-shelf solution for the customer from a range of existing products. Once the product, the customer requirement is assessed for volume, measures of success, the manufacturing process, costs, scalability, time scale, then we can work through these variables here. We can choose the right material. Haydale does not make graphene. We've got hundreds of grades we've assessed, but we also use carbon nanotubes, boron nitride, and other materials. We're agnostic to whatever provides the benefit to the customer. We can then choose the chemistry: oxidative, carboxylic, amines, silanes, hydrophobic, hydrophilic, depending on the need. We can tune the level of chemistry. That's key because too much functionality can alter the formulation or mask the properties of graphene that you're trying to provide. They go in our plasma reactors. It's a single stage, high volume, worldwide patent protection, environmentally friendly process, but we don't stop there. We take the powders and we can put it into an intermediate. We've got our own manufacturing facility here in the UK for that. That means we can provide it in a master batch, resins, solvents, or we can even make finished goods such as inks that can complement the customer's requirement. That's all of those variables then are focused on the end use for the customer. We've got a fleet of reactor designs: HT60 lab scale reactor system, HT200 pilot plant, HT1400, what you saw in that initial video, volume manufacturing, and we've also got a HT4000 system designed to support the higher volumes. Being able to provide the end-to-end solution for a vast range of applications requires tunability. By taming the chemical reactions that occur in plasma, Haydale has been able to tune in the types of chemistries and levels. This is not just by changing the feedstock of chemistry, i.e. switching out oxygen for nitrogen, but we can also select the specific chemicals required, such as primary, secondary amines, or hydroxyl or carboxyl. The infographic on the left shows how we can tailor the effective dispersion in the solvent. This is key as we target either electrical, mechanical, or thermal conductivity in an application. Haydale can then take the bespoke powder, disperse them into a matrix that the customer can deal with, such as a master batch, or even produce a finished product, such as a printable conductive ink. We're applying these to a vast range of product applications driven by customer demand such as lightning strike protection for aircraft, tooling for jet engine blades, diagnostic sensors, blood glucose diabetes, test devices, batteries, automotive wheel arches and body panels, diagnostic sensors, elastomers, shoes, foams, tires, sports equipment, cycling frames, electronics, underfloor heating, garments, and thermal fluid. Haydale has a number of off-the-shelf printed biomedical sensors that utilize our functionalized graphene. Haydale's biomedical inks present the next generation of solutions for monitoring chronic conditions such as diabetes and detecting other medical conditions. Functionalized graphene also provides improved accuracy, flexibility, and speed to patient tests. This is an award-winning product for microRNA detection in kidney disease, and it's also been shortlisted for the Engineer C2I Awards 2023. Functionalization has been very, very key to our biomedical sensors. Through functionalization, we've been able to improve the dispersion and homogeneity, as you saw in that first video. That results in improved testing consistency. We're also able to select the right chemistry and the purity of that chemistry that helps with the sensor read rate and accuracy. But also very important is this new material, new functionality can't affect the manufacturing of this product. So printability is key. We don't want to see increased viscosity. That means it can't be manufactured through traditional printing methods. And also it can't affect the cure profile at the end. Another case study is our heater products. Haydale has unlocked the properties, electrical and thermal properties of graphene using our plasma functionalization in a range of conductive heater inks. These have been used in wearable functional garments in Tokyo by a medal-winning athlete, but these heaters can be printed into different shapes and sizes and are compatible with all modern construction materials. It's a cost-effective and low-carbon alternative to existing underfloor, mobile, and overfloor heating solutions. As an underfloor heating product, central heating, if you will, it's easy to install for retrofit and new build, enabling degasification of the nation. The need for functionalization in this has been paramount. We need to make sure we've got the right matching chemistry. This is how we get the heat output, no cold spots in the heaters. We need to be able to improve the bulk conductivity to that particle-to-particle interaction. That's allowed us to enable lower voltage systems. And printability, again, is key for this one as well, allowing our product to meet the volume market demands. As you can imagine, with the current climate, being able to produce very, very, very efficient heating systems is going to be key, but you've also got to be able to do that in volume. Elastomers and bike tires. Haydale, an Italian bike tire manufacturer, Vittoria, have co-developed improved rubber compounds for better tire performance using functionalized graphene. Functionalization offers substantial improvements in grip, rolling resistance, puncture resistance, and durability. This product has been developed through an iterative process where we've identified the right grades of materials, as you've seen throughout flowchart, and a number of functionalities, tuning them in to the right type of chemical groups and level to provide the benefit to the customer in their specific elastomer formula. The functionalization needs to be able to complement vulcanization, so to ensure the product finish, and again, manufacturability. Mechanical requirements, we've got to get the functionality to get the interaction with the matrix, to get the better performance and long-term, longer product use life. But also this needs to maintain or improve shelf life. You can't have it affecting the properties of the elastomer, then being detrimental to the shelf life of the product. Other applications that we're working in, there's many, many applications, as you can imagine, for these advanced materials. Some of the ones we're working in are epoxy composites, tooling, better product life, better surface quality, improved homogeneous cures, tighter tolerance parts, reduced manufacturing costs. We're working in packaging, food storage, mechanical and barrier properties of thin films, uniform dispersion of thermoplastics, improved hydrophobicity, conductive lightning strike solutions for aerospace. That's the improved conductivity there. We're also working in paints and coatings, next generation thermoplastics, and many others. We are focused on commercializing a few key of our own products, although we're able to support many customer requirements and manufacturing needs. Through surface engineered functionalized nanomaterials, Haydale is further enhancing the world we live in. At Haydale, we have the capability to functionalize a range of nanomaterials to realize the customer's requirements, take those nanomaterials, work with our in-house experts to formulate and develop the manufacturing requirements against the customer's requirements, supporting innovative products and volume manufacturing. We provide the end-to-end solution to give graphene the power to change lives. Thank you very much, Terence.
Thank you, John Mark. Appreciate that pretty comprehensive overview, your approach to graphene functionalization and then how it's used. And what I'd like to do at this point is go straight to Kevin Keith over at MITO Materials to share what they do. Now, we have two companies that do functionalization. They both do it in very different ways, but they do it with the end objective is to improve the performance of the graphene materials. So we're going to hear from Kevin Keith, one of the co-founders of MITO Materials based in the United States. So let's hear from Kevin. And then after this presentation, we're going to go to Q&A and we'll be able to take questions from the audience. And I do want to give a shout out as well. MITO Materials went through our verification process recently, and they are a Graphene Council verified functionalized graphene producer. Mm-hmm. We appreciate your participation in that program. So Kevin, go ahead and let us hear what you have to say.
Yeah, thanks, Terence. So at MITO Materials, everything that we do is pivotal on functionalization. We pair a lot of different scaffolds, whether it's carbaceous or non-carbaceous materials, with organic and inorganic chemistries to better unlock the properties, handleability, and dispersibility of those scaffolds. We are market leaders in turning traditionally hard-to-use materials, so things that you usually see in research papers that undergo very specific mixing and functionalization instructions, and turning those into scalable products. We believe that material improvements are life improvements. So when I say that, what we really mean is that while metals, everything has been squeezed out of that rock, we want to bring that multifunctionality to polymers. So whether it's thermosets, thermoplastics, we're here to impart not only mechanical properties, but thermal, electrical, hydrophobicity, you name it. We want to gear towards it and incorporate at least two or more things into one material. So what we bring is an understanding of graphene characteristics and how to use those for functionality. So, whether it's flat, wrinkled, crumpled, how it alters through the process to get different mechanisms, whether it's thermal, electrical, hydrophobicity, wet out handling, we understand it. It is a patented scalable process that is decentralized. So it's a process that we've developed, that it's a wet process, semi-dry, wet. We can shop out this tech pack to chemical manufacturers and they can make it. So if we need more scale, we just onboard more tolling manufacturers. Our organic and inorganic chemistries make ease of use because as it comes out of the process, it is a micron-sized material, which is great for EPA and TSCA, just because they don't want anything below 10 microns, and I don't want to handle anything below 10 microns because standard HEPA equipment can't really handle that on an industrial scale. So we make these micron materials, and as it lets down into the polymer, it goes more submicron. The micron-sized particles require that low energy dispersion, so we don't have to do ultrasonication, and it's a very easy mixing solution to where we can just go inside with a drill and paint mixer and integrate, because everything that we come to the table with is introduced not with disruption, but with integration. So for instance, one of our flagship products is a graphene oxide-based particle, to where with 0.1% by weight mix of the resin, we just weigh it out, put it into the system, and then it's just an easy shear mix to where it reactively disperses throughout. And so we've done this with thermosets, thermoplastics, and when you cast it, what you see under an optical microscope at 40x is that it is dispersed. These black particles are more stacked layers, but they still have that chemical functionality to better increase that surface interaction that you really want from these nanomaterials. So whenever people sonicate, whenever you're trying to get that very homogeneous dispersion, what you're really trying to do is you're trying to create that flat monolayer content so the polymer can better adhere to it. Why not do that with chemistry? So everything that we do here is a very compatible, easy to integrate, handling, integration, multiple delivery methods. So that way we can come to you with a product, with this one product, and you can plug it into different steps along the way. So for instance, our first public customer is Folsom Custom Skis. So last year, they were trialing with our product, and what they found is that with 1%, so 10 grams for the whole set of skis, they were able to increase strength by 35% and damping properties anywhere between 100 and 200%, depending on the fiber. This got them really excited because they can never find any graphene supplier that would sell them less than 300 kilos of the stuff. And even then, it was nanomaterials. He didn't want to handle it, and so he just put it on the back burner. But with this product, they went back to the drawing board, and what they found is that they were able to decrease the weight of the ski by 18%. So they were able to save ultra-high molecular weight polyethylene, carbon fiber, wood, and steel just by with this 10 grams of product. So they were able to make an ultralight ski that is then able to actually be worth something. It doesn't chatter. You can still control it. It's a really nice ride. And this is important because they undergo a lot of flex, tension, and compression, and almost anything in the world that uses composites is undergoing that. So it's still a good proof point to then shop out to, say, automotive, transportation, or aerospace. Another use case should be going public hopefully soon is a fishing rod manufacturer that they are a very highly engineered American rod manufacturer over in Wisconsin. They make about 500,000 units a year. And coincidentally, their lead engineer, he designed a fly fishing rod for another buddy of his, and it won the International Rod of the Year. So they are incorporating ego into that rod that they are designing. So with 0.05% by weight, they were able to increase flex torque by 47%, the sensitivity by 27%, and snapback, essentially how quick it settles back to shape. And that was just within a spray solution onto their prepreg, so they didn't have to go through the compounding process. This product can be made into a prepreg, but going back through that supply chain, it can be very long and tumultuous and take years and years to enable that material adoption. So right now they're incorporating this product into about 1/5 of their product line, and they should be going into about 375,000 units in the next 12 to 18 months. Another use case, this prepreg customer is a golf club head manufacturer, to where they're one of the top 5 club manufacturers in the world, and they've always wanted to use graphene, but nothing has really worked. They've tried and tried again, whether it's nanotubes, graphene oxide, nothing's really gotten to stick. So we worked with their contract manufacturers. We made a unidirectional carbon fiber prepreg that was made on site. So they took the powder, they put it into the resin, they put it through their hot melt system, and they made prepreg with some Toray T700 fiber. And what they found is that with 0.5% by weight, the product increased flex strength and modulus by 20%, as well as stiffness by 15%. So again, this allowed them to go back to the drawing board and use less carbon fiber and less resin, which allowed them to redistribute that weight, but also to save some greenhouse footprint, because carbon fiber is one of the most greenhouse intensive products in the world. And that's 10% of that weight. So if you're taking out 10% of that, you're saving 10% of your greenhouse emissions. So still with the same product, you're able to go into more thermoplastics, more thermosets, vinyl esters, polyesters. We've seen with this one product, one functionality, tuning the loading, you're able to get vinyl ester performance increases upwards of 85% in the compressive direction, as well as polypropylene performance 20% without fiber. I mentioned without fiber because generally we've seen that with this chemistry that we've been able to develop and the scaffold that we paired with this inorganic chemistry, that it favors the fiber adhesion. So you're therefore not only increasing the surface interaction of the particle to the polymer, but you're also increasing the adhesion between the fiber and the substrate. And that's what I mean by multifunctionality. So thank you everybody for your time today. Very open to questions. I love answering questions more than anything else. And thank you.
Well, first of all, I
Okay.
want to thank both of you guys for sharing the information that you presented and especially your time. We have a number of questions, so we'll kind of jump through that and we'll get started. One of the questions was the original form of graphene that's used, and I'm going to try to combine some of the questions here. I think, Kevin, you guys start with graphene oxide as your starting material. Is that correct?
That is correct.
And then John Mark, the question, is there a particular type of graphene that lends itself to functionalization? And I know with Haydale, you guys have been at this for over a decade and have used hundreds of types of graphene. Is there a particular type of graphene that does it matter?
No, we always focus on the end performance requirement to select what type of graphene to use. For functionalization, we functionalized all types of graphenes, graphites, carbon blacks, carbon nanotubes, even traditional materials and organic fibers. They're all susceptible to functionalization, but it's not necessarily an academic exercise. We're always looking at our past experience and targeting the customer performance requirements.
Understood. And Kevin, just to be clear, MITO Materials doesn't produce graphene either, right? Your specialty is the functionalization.
Correct. So we can use graphene oxide, graphene, other types of scaffolds. And so what we view ourselves as, everybody else is supplying the marble to us, which is already very beautiful, very moldable. And we're able to create the statues, the artworks. So we're able to take this material, do our wizardry to it, if you will, and then we're able to make a more dispersible, handleable material to actually lower that barrier to entry for those advanced materials.
And one of the questions had is, in the case of the graphene oxide, do you consider it still to be graphene oxide afterwards? And maybe for both of you to answer, what is this material that we're actually ending up with? Because graphene might be the base and then there's an alteration to it. What is it that we end up with? Kevin, do you want to start first with that?
Yeah, for sure. So we consider what we produce a hybrid material. So Ego, it has this silane case structure to it that it pairs an organic inorganic with the graphene oxide. By the time we get to the end product, we consider it that hybrid material because it's way more than just graphene at this point. There's a lot of complex chemistries going on that allows it to be what it is. So while our starting material is graphene oxide, graphene, it comes out different because what we see is traditional graphene oxide. It has that either amine functionality, the oxygens, what have you, but we're adding a lot more to it than what went into the system.
Excellent. And John Mark, how would you?
I think we just describe it as a functionalized material, so surface treated materials. Most of the customers we deal with, from their end, it's just a bespoke additive for their process too. So being able to get that functional groups so that there's no detriment or impact to the manufacturing process, then it can just be considered as an additive to their process as well. I think one of the questions there was about the types of functionality. So there's such a range of functionalities that can be achieved: oxygen-based silanes, amines. Our precursors are either gases, but we've also developed liquid dosing and solid dosing chemistries into the reactor. So there's a huge plethora of types of functionalities that can be applied to materials. So I think the best way we consider it is it's just a bespoke additive.
Excellent. Inevitably, there's going to be a question about cost and price of this. With graphene in general, to give this some context, we've been at this now for 10 years as the Graphene Council, and one of the primary objections raised to using graphene is the perception that it's just too expensive as a material. And of course, both of your companies are adding a process to graphene that's already been produced to do the functionalization, to further process it, which adds cost, obviously, right? You don't do this for free. But I also want to point out that if it wasn't clear to people who are watching this or who are not familiar with it, the load factors that you had mentioned in some of the actual applications and examples were less than 1% or tenths of a percent or hundreds of a percent by weight. So can you guys just talk a little bit about this kind of combination of, you have graphene as a material, you further process it so it's more effective. It then allows you to put it into a host material to get the desired engineering outcome at extremely low load factors. What do the economics of this look like? And for you, John Mark, I'll ask you to go first on this, but talk about the economics of using these enhanced materials, and what are your customers telling you?
Yeah, so this is why we've got that sort of end-to-end holistic approach. I think it's important to assess the customer's need to make sure that it is a suitable solution for them in their application, especially looking at the volume required. But then once you functionalize the material, it's just a formulation step. So a lot of industries are already using dispersing agents, high shear mixing, trying to get traditional materials to work. So once you look at it holistically and look at the processes used, the functionalization is just a manufacturing method that may replace or improve manufacturability. I see some of the questions there sort of lend it to that, increasing the electrical conductivity of graphene. So functionalization can actually boost the performance of these materials as well, giving them a further performance improvement. And then, as you mentioned, the loadings are quite low as well. So I think it's important to look at the whole solution across it and see how functionalization can affect the manufacturability and performance. And then you'll see your cost benefit come through at the end.
And Kevin, how would you thank you, John Mark. Kevin, how would you address that question about on the economic side of it?
Yeah, that is a really good question. So when we think about the economics of it, really what we're bringing to the table is a value add. And so by the time you incorporate the material, you have one of three scenarios happening. You have a cost negative because you're taking out material. You have a cost parity because while you're still putting in ego, you're taking out material. And so it's about the same. Or you have a cost positive to where you have an increased cost, but you're having an increase of, anywhere between 50 and 100% in a certain material property you were looking for that directly integrates into your process. So while typically in the past, graphene has been looked at as, oh, it's too expensive, like a whole laundry list of reasons, it's the fact that we're solving those key pain points to be able to capture that value and to ease that integration. And it turns out that when you deliver what you actually promise, everything that has been promised about graphene in a very easy, simple letdown process, a lot of people are willing to go for it.
Well, the other observation I would make is the Graphene Council, we've seen this across different applications, is you have this direct, right? You can use less material, you got less embedded CO2, which are some of the direct obvious ones. The other is, improved processability or longevity of the product, better recyclability. There are often tangential benefits that most people aren't really thinking about when they first say, okay, we want to engineer this to make it stronger, lighter, et cetera.
Right, because if you can turn for instance, if you can turn a car A-frame into a composite material, but it can also hold a charge because it's more electrically insulative, then you're turning something that traditionally had one use into a multifunctional material that you can supplement, and it's a whole trickle-down effect.
Absolutely. Now, I'm going to raise a question that is a kind of an Achilles heel or a sore spot, and that's the regulatory environment. One of the questions was raised, and we don't want to ignore that. And of course, the Graphene Council is engaged directly in the United States with EPA. We know that graphene has been REACH registered in Europe. How would you guys address the issue of registering these derivative chemicals and materials in your respective regulatory environments? John Mark, do you want to start with that one?
Yeah, I think when it comes to functionalization, again, assessing the application is key. But what we've been doing through Plasma is providing very clean and lean chemistries. So they're pretty simple functional groups such as oxygen or carboxyl or amines. And these usually complement the matrix we're dispersing into, so you get that bonding between the two, and that dispersion interaction further improves the binding of the graphene into products, which has got a benefit, but nonetheless, the full sort of assessment, complementing the positive status of reach, but that all needs to be tested in application when you develop a product. So,
and Kevin, what's your perspective on this regulatory issue?
Man, the U.S. is weird. So in the U.S., in order to get approved for regulatory, you can go one of two ways. You can make a really broad claim, companies band together, and you say, we're making a graphene-like material. And then you can cover an umbrella of a whole different slew of materials, and you're okay. That has not been the case to date, and we're really trying to change that. But you can file what's called a low volume exemption, and graphene being graphene or graphene-like materials, you can do that relatively easily. And it's just the same. It's just it limits the amount that you can make, but it's still like 10, 15 metric tons of material. And if you're loading it at 0.1% at the higher end, you're still making, oh geez, what is that? 10 million metric tons of polymer or something like that. Like it's an insane amount. So double-edged sword, but we're working towards it. And luckily, NIOSH is doing a study of different graphene and graphene-like producers, and they're gathering that data to better aid EPA to lower that barrier to entry for the regulatory and to ease the process to where you don't have to pull teeth to get through it.
Absolutely. We've done a lot of work collectively as an industry and through the Graphene Council of working with EPA to inform and educate. And I know that there's a graphene consortia in Europe for the REACH registration where the companies have come together to do that collective one. I think it is a matter of educating and informing the regulators and being transparent with them about what we do with graphene, how we use it. And if you compare graphene, which is basically carbon, even in the functionalized form, as you both have described, it's a rather benign material compared to many other chemicals that are widely used. So, and used in very, very small quantities and then fully embedded into a host material. So I think it's, its profile for exposure is a lot more benign than what else is commonly being used. There's a very specific question about high density polyethylene. The question, the attendee asked to be anonymous, but the question is, we are considering adding graphene to HDPE to extrude into large 30-inch pipes to be used as load carrying columns. How would the added graphene impact the compressive strength of the enhanced HDPE pipes? Now that's a very specific question. We know that graphene has been used in high pressure pipes and polyethylene pipes to improve the strength to the point where the wall of the pipe could be reduced and retain the strength profile. So that would be my observation on that. But do either of you want to address this or have any experience with HDPE?
Yeah, I think for us in our experience is getting that specific functional group. So you've got that interaction. You've got to make sure that the graphene doesn't change the properties when you're extruding it, making it too many agglomerates, too brittle. So we've seen functionality as a very, very important aspect of that. What we do is we work in master batches. So we would provide a high loaded system, then it can go to the plant where they do the extrusions and be let down to the required level. So that's, I think, my only comment on that aspect of it.
Kevin, do you have a comment on that one?
I sure do. HDPE is one of those tricky materials to where it's not quite like PVC, but nothing wants to interact with it. If you can get the chemistry right, and if you can get the loading right, it would do a whole lot of different things than boost compressive strength through the roof. So for instance, if you take a certain functionalized graphene or other scaffold material, you get it to disperse, we have found that with our products, we're able to go into that HDPE and it compounds really, really great. There's no agglomerates, really easy to let down directly into the system even. It cleans up really nice, but there's no interaction. We get a flat line. And that's because HDPE doesn't really want to interact with a whole lot. But if you get the loading right, you can increase that gas barrier property significantly. It's something like O2 gas barrier permeability goes down 100% with something like 0.5 or 1% by weight loading of that graphene. So I encourage everybody here that if they're thinking of a very hyper-specific property for graphene, to broaden your horizons a little bit and look at more than just that one hyper-specific thing. Maybe look through some laundry list of attributes that you're looking for and see if you can tick off a couple of those boxes.
Excellent. So there are a lot of questions that we're getting from the audience about, specific uses. One is, can we use graphene in batteries? Can we use graphene for protective coatings? Can we use it in medical applications? I'm going to ask a very broad, very simplistic question. At the beginning of the introduction, I showed, there's 45 different industries and there's all these different vertical markets. Is there any application for graphene as a material that functionalized graphene cannot address? And does functionalization open up applications that graphene by itself unfunctionalized cannot address?
Yeah, I think you sort of answered it there. It's part of the challenge we've had is there's a huge amount of applications you could put graphene to, especially functionalized graphene, and broadens that aspect of it as well. This is why, as I mentioned, it's our first assessment to see that customer's application. Is the volume there? Is it cost beneficial to do this? Because in not all cases it is. But I think being able to down select with your customers and finding out what their applications are, as Kevin mentioned, they're looking broadly at the application need to see where we can complement it. I think what we've seen in the last couple of years with the economic and climate and all these other sort of considerations is people are trying to lean down and get further with their products as well. So the needs now for graphene are getting a lot clearer in applications as well. So instead of having this broad graphene can do everything approach, we were joking earlier when we joined the call about space elevators and this sort of thing. It's actually about making things more sustainable, more cost effective, more simple formulas. And I think they're the sort of near-term applications that graphene really lends itself to. People have tried it before, but this is where functionalization comes in to make it manufacturable, get that dispersion and scalable as well. So I think it's a bit of a yes on that, but focusing a bit more about what is the near-term requirements. So, yeah.
Kevin, do you want to add to that?
Yeah, it's definitely the paradox of choice. The more buffet options you have, the less you're going to choose and the more overwhelmed you're going to be. So graphene in the past has promised the world and everybody is overwhelmed by those attributes that you can add to it. Functionalization doesn't help, but it helps with the surface interaction. So sometimes, if you put a graphene into nylon, it's going to interact okay. You're like, okay, well, this was kind of a joke or a scientific thing. But if you put a functionalized graphene in there, depending on what functional group you add to it and you put into that nylon, you can create a nucleating site, which means you make it way more brittle and you don't get the properties that you're looking for, and it looks really, really bad. So it's definitely a dance. I suggest reaching out to somebody and kind of getting an understanding of, hey, what do you think it would do in XYZ? We're kind of looking at this, and here's some other things that we're, pondering of what can it do? Because this is just more than graphene now. We're in that next evolutionary step that it's not just toss it in and kind of see what happens. It's more custom tailoring that loading level as well as that chemistry, because whether we realize it or not, chemistry is all around us, whether it's from the coating on our water bottles to the shampoo we put in our hairs.
I'd like to make some kind of a summarizing statement about this as we tie this up. And I really appreciate both of your time, and I hope our delegates, people participating, take advantage of your expertise. Your contact information will be shared, of course, and hope they reach out to you. But let me say this. There have been an awful lot of folks who have looked at graphene in the past and it failed, right? And so they said, it's too expensive, doesn't work, doesn't deliver on the promise. And what I would say to everybody who has thought of that, there's a couple of things. One, the production process of graphene itself has improved dramatically over the last few years, including scalability and tunability of the material. And added on top of that, companies like Haydale and like MITO Materials, who can then functionalize it and take it even further to match it to the matrix you want to put it into. Graphene deserves a second look, especially when you think of the performance improvement you can achieve for the extremely low load factor at prices that are commercially workable, right? Because of the low load factor and because of the lift in performance you can get and the offsetting benefits with less material, less embedded CO2. So for those who have tried it and said, graphene, it doesn't meet the hype, it's worth taking a second look at with people who can help you get over that engineering field.
I saw one question there about how long it can take to develop as well. I think especially through functionality and the history that both companies here have got, the development sort of gestation is a lot shorter now as well. We'll be utilizing our previous case studies and experience and then expediting the results through functionality. So again, the development cycles for this product is a lot shorter as well. And they're a lot more bite-sized with the understanding of graphene too. And that really lends itself to having a look at it again of our previous success and keeping a lean project there. So.
Thank you. But I would also say there was one question just asking, about resources and things like this webinar and videos from the Graphene Council. We do have a YouTube channel. This will be posted to that. We have a really extensive library of videos now that really get good viewing. Please look at the YouTube channel. We'll send you the link, and of course, subscribe. So when new videos are dropped, you'll be the first to know about it. The Graphene Council does not sell graphene. We're an independent, neutral body. We're really proud to have both Haydale and MITO Materials as members of the Graphene Council, and we're here to help you connect with companies who can help you with these solutions, as well as provide you independent third-party information and feedback about this process. So as we close here, I'd just like to ask, John Mark, if you have a closing statement, and then I'll ask you, Kevin, and then we'll wrap up today's webinar.
No, just I'd like to thank you again, Terence, for organizing this, and the pleasure to speak to so many people about what we believe functionalization to be a future industry norm, if you will, chemical engineering that can provide benefits to a whole range of traditional and advanced materials such as graphene. So thank you very much.
Appreciate you. Thank you.
Yeah, I'd like to echo that. Really appreciate you taking the time and taking the effort to set this up. I know it's a lot of cat corralling, if you will, trying to get everybody into the same room. And everybody that's here, I really encourage you to kind of think through your experience with graphene, kind of look at, okay, well, what could we really solve if we really solve the problem of dispersion or interaction or whatever it may be that failed the last time? Because probably the first half of my almost 10 years experience in this is that nobody knew what graphene was. And then the people that did, they said it was garbage. So we're fixing that. Kind of think through, reach out to one of us, and we will help you with your graphene integration and solving your problems.
Thank you. We're very proud to have you guys as members. Really appreciate you. And of course, the huge teams that stand behind you with the work that you do. For everyone who participated in the webinar, we appreciate you spending time with us. We'll send out the links to the recording and a copy of the presentation slides. You are free to share them within your professional networks. Our mission is to help educate people with fact-based information about what graphene can and cannot do and how to access it and unlock its potential. And that's why we're here. And we're very excited for this next year for what graphene offers, especially in light of improving products to reduce embedded CO2, make products more recyclable, make them better, lighter, stronger. It's really an exciting time as this industry matures. So with that, wish everybody a great 2023. Thank you guys for spending your time with us and sharing your expertise. It's always appreciated. Take care.
Thank you very much.
Thank you.
Bye-bye.